Hello my dear students, कैसे हैं आप सभी? We are talking about rotational motion, and if we are comparing the rotational motion and translatory motion, the rotational motion and linear motion, okay, linear motion or translatory motion, so we can compare angular momentum and linear momentum also. So what is the angular momentum? What is concept of angular momentum? To understand the concept of angular momentum, first we have to understand the concept of moment. What is meaning of moment? If we are taking moment of linear momentum, it is called angular momentum. So what is meaning of angular momentum? Okay, the definition of angular momentum is moment of linear momentum. Let us consider it is axis of rotation and a body of mass m having linear momentum p vector. This is the radial vector r vector. Okay. So if we are, this angle is theta, if we are resolving this p perpendicular to this r, means what is meaning of moment? We are multiplying the perpendicular distance with linear momentum. Okay, so this p sin theta into r is called L. L is r into p into sin theta. Okay, so how we can define angular momentum? It is the moment of, if we are multiplying, what is meaning of moment? If we are multiplying the perpendicular distance, it is called taking moment. Okay, so moment of linear momentum is called angular momentum, and this angular momentum we have to consider for point mass, for rigid body, for translatory motion and for the rotational motion. The concept of angular momentum also valid for translatory motion, okay, and rotational motion. So L is equal to r p sin theta. If this L we want to write in vector form, so it will be r vector cross p vector. It will be r vector cross p vector. We are taking a special case in which theta is equal to 90 degree for point mass. Means this is axis of rotation, this point mass m, this particle of mass m is moving with velocity v and having a distance r, like that. So angular momentum is mvr. The angular momentum is mvr. Okay, it is only for the point mass, but if you talk about the translatory motion, if you talk about the rigid body, we have to use this. L vector is equal to r vector cross p vector. It is the cross product of radial vector and p vector. It is the cross product of radial vector and p vector. So since it is a cross product, it should have some direction. Okay, so what is the direction? It is a vector quantity. So what should be the direction? In the direction of cross product and p, or we can say in the direction of omega. Okay, how? We will see later. Okay, so in the direction of axis of rotation. Okay, and what should be the unit? It should be meter, kg meter per second into meter, means kg meter square per second. per second unit. If we talk about the dimension formula, it is ml2t minus 1. It is ml2t minus 1. Okay. So it is the concept of linear momentum, angular momentum. Okay. Moment of linear momentum is called angular momentum. So this concept is only for the point mass. If we talk about the rigid body, rigid body can perform rotational motion as well as translatory motion. So for translatory motion, the concept of angular momentum is different. Okay, and for the rotational motion, concept of angular momentum is also little bit different. So first we are talking about the angular momentum for translatory motion. Okay, how? Let's see. So the angular momentum for the translatory motion, let us consider a rigid body is moving translatory with velocity v, means the velocity of center of mass is Vc. Okay, it is the velocity of center of mass, it is the center of mass C of center of mass. Okay, and we want to find the angular momentum about O, about this point O. Okay, at an instant, let us consider this center of mass at position r vector, having position r vector. So what is the perpendicular distance of this? This is the perpendicular distance. If this angle is theta, it is r perpendicular, which is equal to r sine theta. Okay. So in translatory motion, what we can consider? We can consider whole body concentrated at a single point, which is the center of mass. So we have to take angular momentum of the center of mass in the translatory motion. So the angular momentum for the translatory motion is mass of the body, its velocity Vc, it is the linear momentum into the perpendicular distance r perpendicular. So it is equal to angular momentum for translatory motion is equal to mvc r sine theta. Okay, and in vector form, what we can write? M r vector cross vc vector. Okay, it is very important to remember, it is r cross v, not v cross r. If you want to find the angular momentum, the direction of angular momentum is in the direction of r vector cross v vector, not v vector cross r cross v. Okay, otherwise there will be mistake. So it is angular momentum for translatory motion when body having velocity of center of mass Vc. Okay, we are finding the angular momentum of this body which is moving with velocity Vc. Okay, and the distance of center of mass is r. Okay, so whenever we are talking about the translatory motion, we have to know about the center of mass, we have to know about the velocity of center of mass. Okay, only we have to study the center of mass in translatory motion. Okay, and with the help of center of mass, the motion of center of mass, we can differentiate rotational motion and translatory motion. It is very important. We are talking about the rotational motion, and if body is rotating about any axis passing to the center of mass, what should be the angular momentum of this rotating body? It is called angular momentum for the rotational motion. Okay, let us see. Let us consider this rigid body is rotating about this axis which is passing to the center of mass. Okay, with some velocity, angular velocity omega. It is the angular velocity omega. Angular velocity omega. Okay, it is kind of rigid body. So we can consider a point mass m1 which is velocity v1 having velocity v1 at distance r1, same as it is m2 moving with velocity v2 having distance r2, same as it is mi having distance ri velocity vi, and mn rn vn. We can consider n part. We are talking about rotational motion. So, my dear students, if we want to find the angular momentum for the rotational motion, okay, angular momentum for the rotational motion. What is meaning of rotational motion? If body is rotating about any axis passing from the center of mass, it is called rotational motion, and we want to find the angular momentum of the rigid body. Okay, let us consider it is moving with omega. So, what we have to do? We have to add the momentum, angular momentum of each particle of body. Okay. So, let us consider a rigid body, okay, and it is the axis of rotation which is passing from the center of mass, and whole body is rotating with omega, with angular velocity omega. It is the angular velocity omega. Okay. To find the angular momentum of complete body, what we can do? We can differentiate, we can divide this body into n particles. So, m1 having distance r1 moving with velocity v1, okay, m2 having distance r2 moving with velocity v2, same as it is mi, ith particle, mi having distance ri velocity vi, mn nth particle, rn velocity vn. So, the total momentum, angular momentum L is momentum of first m1 r1 v1 plus momentum of second m2 r2 v2 plus up to momentum of nth particle mn rn vn. Okay, we can write this as summation I equal to 1 to n mi ri vi as summation mi ri vi. This vi can written as omega into ri. Omega is same for each particle, it is angular velocity is same for each particle, because each particle is moving same angle in same time. Okay. So, omega into ri. Now, we can put L is equal to summation I equal to 1 to n mi ri omega into ri. Okay. So, L is equal to summation I equal to 1 to n mi ri square into omega, and this term can written as I, the moment of inertia. What is the moment of inertia? Moment of inertia I is equal to summation small I from 1 to n mi ri square. You know very well. Okay. So, this is the angular momentum for rotational motion. It is a vector quantity. So, it should be in the direction of omega. It should be in the direction of omega. And what is the direction of omega? It is the along the axis of rotation. If body is rotating like that, so what you have to do to find the direction of omega? Just rotate your fingers of right hand in the direction of rotation of body. Thumb shows the direction of omega. Same the direction for the L, angular momentum. Okay. So, L vector is equal to I into omega vector, as P vector is equal to mass into velocity vector, same as it is L into I into omega vector. At the place of mass we have to use I, at the place of velocity we have to use omega. So, we can find angular momentum. It is very easy formula. Okay. If we having understanding of all concept of translatory motion, So, it is very easy to understand all concept of rotational motion, as the linear momentum p vector is equal to mass into velocity, same as it is L vector is equal to I into omega. Okay. So, at the place of mass in rotational motion we have to use moment of inertia, at the place of linear velocity we have to use angular velocity. All this concept will become very easy if we are comparing rotational motion and translatory motion. Okay. Thank you very much.